Hi everyone, welcome back to Pine Hollow out of Diagnostics. As you saw, we have another Beached Whale Volvo from Virginia. It's like deja vu. I just got done fixing the 2004 Volvo XC70 all-wheel drive from Virginia. And this one got towed in last night, 2004 Volvo XC90 all-wheel drive from Virginia. Same story, guy who doesn't speak English in an F-150 truck with a flatbed trailer. I'm like, oh, here we go. I hope they didn't mess up the suspension with the track bar, but this guy was actually professional. He had straps on the tires holding down the vehicle to the trailer, so that was a good thing. Went a lot smoother. So this Volvo, what's the customer complaint? Well, obviously it doesn't start. Most of the time it doesn't start. Sometimes it does start. It doesn't run very well. Let's read the customer complaint here. Hard to start. Recently the check engine light is on. However, once it starts it runs fine. Been to dealer and couple shops and could not fix it. Would be difficult for me to bring it to State College. If you happen to come to Virginia, car's waiting for you to take a crack at it. Otherwise, I'm considering donating it to charity. Well, I convinced them to get the car here to my shop because even if I diagnosed it in the field and wherever, it still wouldn't be fixed. So here it is. I'm excited about this one because it doesn't look too butchered under the hood, unlike that wagon over there. We have the battery charger hooked up. Battery was spanked, so 13.5 volts. Let's see what the health report shows. So keys on, we have reduced engine performance, interesting. And I did a health report last night, saved that right here. Let's take a quick look. Let's see, central electronics module. Also I noticed I couldn't take the key, I couldn't turn it to lock. Sometimes you can, but most of the times you cannot. Interesting symptom there. He said sometimes that happens. So, let's go right into engine control module. Engine speed RPM sensor, turbocharger control signal too high, mass airflow sensor, engine speed RPM sensor signal missing. Okay, so if it's missing the crank signal, that would definitely cause a problem. So here's our tree. Now, I called the owner up. I'm like, what is the history of this car? When, because he said that, like, you know, when did this problem start? He said 3 years ago, the car had a big oil leak at the rear main seal. The engine was removed, the seal was replaced, so the oil leak was fixed. But he said ever since then, it has been a long crank time. Sometimes it takes many tries to get it to start. Once it fires up, he said it ran fine, ran smooth, no check engine light, car's happy. But it right after that repair, had a long crank time. Now, it usually doesn't start, crank no start, and it sets the check engine light with this crankshaft position sensor signal. So that's a big clue that this problem started when the engine was removed to replace the rear main seal. Now, why did the rear main seal blow at 130,000 miles? I don't know. I think these cars have issues with the PCV system. Maybe it built up some crankcase pressure and blew that seal out. Who knows? But we're here to diagnose this crank no start. So what I'm going to do is clear out all these codes right now. I'm going to start from scratch. We'll crank it over, see if codes are set right away, and go from there. So the only 3 hard faults remaining are siren communication fault. Man, this is deja vu. The other Volvo had exactly the same codes. Air quality sensor internal fault. Same exact codes. I don't know what to say. Steering wheel out of alignment, incorrect steering wheel alignment. Okay. So let's turn the key off. Again, I can't take it out even though we are in park. The owner said sometimes you slam it in park. There you go. See, I took the key out. Let's try again. Okay, let's crank it over. Look at that RPM needle. It was like boing, 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 boing. Okay, so let's go to the ECM, see if it set a code right away. Okay, so 3 codes right away. Turbocharger control signal too high. Mass airflow sensor signal there. Interesting. And engine speed RPM sensor. 5200. Alright, so let's do some research online. See where the sensor lives, what it looks at, the reluctor. You know, was that affected during the engine removal and installation? And then get a scope out, see what this signal actually reads when we're cranking the engine. Well, while we're here, I want to graph 3 data PIDs: engine coolant temp, engine speed, and mass airflow. Let's crank it over. Ooh, it almost fired up. Look. Ooh, not happy, not happy. Okay. So we'll take a screenshot of that. I guess it lost the data. So very interesting. Once it starts, it ran smoothly, but then it started like going like where like the mass airflow sensor is unplugged or something. We can do a visual inspection on that. See where it goes. Alright, so I'm in generic OBD2 data. These are more familiar trouble codes. So P0102 is for the mass airflow, P0335 crankshaft position sensor A circuit. So that might make it easier to look up the trouble codes. And let's look at the live data in here. Because sometimes the OEM side uses substituted values, but OBD2, they must report the real actual values in the live data. So engine RPM, engine coolant temp, mass airflow, throttle position, intake air temp. That's all we want to look at. Okay, let's crank it over. Okay, we did have 0 grams per second from the mass airflow. Very interesting. And when you release it, the data drops out. But the RPM stayed pretty stable. Maybe it's reporting RPM from the camshaft sensors. I don't know. We gotta get a scope on these. Let's look at a wiring diagram. Alright, let's take a look at some wiring diagrams. So, doing some research. This is the OE diagram with the actual numbers of the components. There's a mass airflow sensor, 4 wires. It looks like it's tied to the power feed for the fuel injectors. And then there's a ground, ties in here. Then there's 2 wires going to the engine computer. So it could be a temperature sensor in there or whatever. Next, it's called an impulse sensor. This 2-wire 7/25. So if you go 7/25 impulse sensor, it's right there, somewhere on top between the engine and the transmission. Okay. If we look at the redrawn diagrams, the aftermarket, this is actually maybe a little more useful because they tell you the locations of the components. So let's see here. First page, we have our mass airflow sensor, 4 wires. Then impulse sensor, top rear of engine, white and a red. So it's a 2-wire sensor. It looks like a variable reluctance type. Then I want to see what the flex plate looks like for this car. Where does that impulse sensor pick up its signal? So you can see here, here's a better picture. It looks like there's a ring that's welded to the flex plate, and there's like a sync notch, a missing sync notch, so we know approximately what to expect on the scope. So the first check I want to do is just check power and ground at this mass airflow sensor, and then hook up a scope to both wires at the RPM sensor and maybe the signal wire at the mass airflow. Alright, let's start with the test light. So here's the ground, test light works. Let's hook it up to the green wire at the mass airflow sensor. So I do have it back probed, not my favorite method, but we'll avoid poking holes while we can. Let's see if that lights up when I turn the key on. It does. Okay. So it looks like we do have a good power feed to the mass airflow. We could also do the same thing at the green wire for the injector. Yes, we have a good power feed to the injector. We could check the ground at the mass airflow. Now, let's see if we go to engine management. You can see the violet and white that's on pin 4. So 2, 3, 4 should be a ground. Well, a little confusion in the wiring diagrams. That purple and white isn't the ground, it's a shared 5-volt reference. That's fine. So where is the ground? I think it says gray and white. So if you plug in a test light from battery positive to here, you can see 220 millivolts. So that's a ground. So we have power feed, ground, 5 volts, and then purple wire. These two go to the engine computer. So that's definitely a 5-volt shared. So the signal must be the purple wire. Let's probe that wire and see what the mass airflow sensor reads when we're cranking the engine. Alright, so mass airflow sensor wire, so signal wire, we got 1 volt, that's reasonable. Let's crank it over, see if that rises. Okay. That's fine. I'm not worried about the mass airflow sensor at the moment. There's something else wrong. It sounded like it, opened up the throttle. Whoa! But then we ran out of fuel or something. Let's focus on this RPM sensor, the crankshaft position sensor. So it's hard to see. You can kind of see it from up top here. That guy right there. Brand new. I think they replaced it twice. So I got 2 piercing probes. You see right through this hole. 1 on each wire, a red and a white. So let's hook up the scope, crank it over, see what the signal looks like. Alright, so 3 channels connected. Blue trace is on the red wire. Red trace, or red wire, or channel 2 is on the white wire at the crank position sensor. And I'm also probing injector number 6, control wire, to see if we drop out injector pulse. So let's set up the scope, crank this thing over, and I expect to see something interesting. Alright, here we go. 3 channels. Key on. See how long it stays running for. Okay, and it died. Very cool. And the key even turned off. Alright. So right there, it's cranking, cranking, cranking. So the amplitude of these signals does look very low. Delta is only 1 volt. I expect to see like 4 or 5 volts during cranking. No injector pulse. And finally, right here, it sped up a little bit and the amplitude increased, and finally an injector fired and it caught and ran. So the signal looks decent. I don't see that much noise on there. 0 to 4 volts. But even 0 to 4, engine running, this should be like 0 to 20, I would think. So are we dealing with an air gap problem on this crankshaft position sensor? So as it's running, the amplitudes, looks decent. They are mirror images. And you see the bias voltage here. About 2.5 volts. So bias is at 2.5, and then it fired up, and on the second page, why did it die? Look at that crank signal. It's just drops out. It was kind of decreasing. I wish it didn't split the page, so it was running fine. Right there, got confused. See that extra injector pulse? That's not supposed to be there. Why did that happen? I have no idea. The signal still looked okay. Was there a glitch? No. You want to look a couple cycles before the glitch happened. There's another glitch right here. Another little extra injector pulse. Bizarre. So I think we have to do a visual inspection on the sensor. I don't like that. It ran pretty decent while it was running, and then after, from 12 to 20 seconds, about 10 seconds, then it just quit. Why would it quit? We could put another channel on the ignition, on an ignition coil. Very interesting. Alright, so I got that waveform saved. Let's do another crank. I'm going to... It's almost like it's running out of gas. Dead. Okay. Very strange behavior. I really don't like these injector pulses right here. That's insanity. They're not evenly spaced at all. So when it first started, it seemed to be pretty happy, except for these glitches right here. How do you explain these glitches? Why is that such a big pulse width and this one's skinny? And it's out of... I mean, maybe it's a strategy. Again, it's European. See, it's basically on. It could be injecting a little more fuel for a, for a rev. But why would it just start dying? It always dies in between screens. See right there, it's like, I guess injected more fuel. I don't see anything really wrong with... I mean, it's kind of wavy, and it is repeatable. You would think if the crank is turning at the same speed, you wouldn't have these changes in amplitude on the crank sensor. See, it's kind of low and then high. It shouldn't really affect the running. I don't like the really low amplitude right here. About 1 volt peak to peak. That's... Why would the computer start synchronizing after 1, 2, 3, 4, 5, 6, 7, 8 engine revolutions and then it'll fire up? So this is the customer complaint for sure. Let's reduced engine performance. I want to get that crank sensor out, measure the gap to the flex plate, maybe spin the engine over by hand, take a look visually at the flex plate. It really, I mean, on a VRS type sensor, if the signal is low amplitude, that usually means there's a gap problem. And they're very sensitive to gap. Like on ABS systems, on the Chevy trucks that rust jack the sensor, a fraction of a millimeter, it doesn't see the speed at low RPMs. That's why newer cars use 3-wire, like Hall effect sensors with a nice digital square wave that doesn't change amplitude. Then we gotta get the sensor out, do a visual inspection, see what's going on there.